September 1939. Britain declares war on Nazi Germany, and Royal Artillery units take up firing positions with a field gun whose roots go all the way back to the Boer War. While the Wehrmacht is smashing its way across Poland using artillery designed in the 1930s, British gun crews are getting ready to fight with weapons based on a layout first drawn up in 1904. Observers in uniform and in suits on both sides of the English Channel are asking the exact same thing. How is Britain supposed to hold its own against a modern mechanized army using guns that look like antiques? The Ordnance QF 25-pounder, the main British field gun of the Second World War, was not a clean sheet design. It was a smart rebuild of the old 18-pounder field gun, the standard British artillery piece on the Western Front that had sent millions of shells downrange between 1914 and 1918. By the time Neville Chamberlain told the nation that Britain was now at war, the Royal Artillery already had roughly 1,000 of these rebuilt hybrids ready to issue. That fact terrified a lot of analysts. Here was the British Empire, supposedly one of the world's leading military powers, going to war with converted First World War guns, while Germany was rolling out the LEF-H-18, a 105mm howitzer, built in the interwar period as a modern system from the ground up. Confidence inside the British Army wasn't exactly overflowing either. Senior officers in Whitehall knew very well that they were sending men into combat with what looked like museum exhibits being dragged behind trucks. A battery of 8 25-pounders could silence a machine gun nest at 12,000 yards without burning up tons of ammunition, tearing up empty ground around it. That kind of accuracy wasn't good luck. It came from a mix of smart engineering, painful lessons learned in the First World War, and the strange restrictions of Britain's interwar budget crisis. Because the designers were told they had to use the barrels they already had, they were forced to squeeze performance out of everything else. They couldn't just design a totally new, much bigger gun with a huge propellant charge. They had to get the most possible effect out of steel tubes that had already survived the trenches of 1916. What the military hierarchy first saw as a weakness, reusing old hardware, quietly became an advantage. The 25-pounder stayed in frontline service for nearly half a century. It outlived a lot of supposedly modern German artillery that was scrapped right after the war. Some 25-pounders were still being used in combat in the Gulf War in 1991. That's remarkable for a gun that first existed when King Edward VII was still on the throne and powered flight was brand new. To understand how it happened, you have to go back to 1904, when the Royal Arsenal at Woolwich finished testing a new type of field gun. The Ordnance QF 18-pounder wasn't Britain's first modern gun, but it marked a break with the past. QF meant quick firing, and that label mattered. Older field guns kicked backwards violently with every shot, forcing the whole carriage to jump and roll. Crews then had to haul the gun back into position and re-aim before they could fire again. The 18-pounder solved that with a hydro-spring recoil system that soaked up the force of the shot and kept the carriage basically still while only the barrel slid back and returned. A well-trained crew could push out as many as 20 rounds per minute in an emergency, which sounded like science fiction to officers who'd grown up with slow-firing Victorian-era artillery. The 18-pounder threw an 18.5-pound high-explosive shell, that's where the name came from, out to about 6,500 yards. By today's standards, that's not amazing. It's only around 4 miles. But in 1904, That made it one of the best light field guns in service anywhere. It also gave the gun a stable pad that didn't deform as much between shots. On soft sand or wet ground, a normal carriage will dig in differently every time it fires, which slightly changes the barrel angle. With the 25-pounder, the platform kept things uniform. Crews could fire dozens of rounds and still hold the same point of aim. The sighting gear brought in lessons learned from millions of wartime shots. Those guns would become the backbone of British artillery for the rest of the war. On the Western Front, the 18-pounder proved itself under the worst possible conditions. At the First Battle of Ypres in October 1914, British crews fired almost non-stop for days, the barrels glowing red as they tried to stop German infantry and keep the line from collapsing. During the Somme offensive in 1916, 18-pounders were part of the infamous pre-attack bombardment that burned through more than 1.5 million shells in 7 days. The blast noise carried all the way to London, roughly 140 miles away. And they weren't just pounding enemy trenches, they were cutting barbed wire, smothering machine gun pits, and laying down close support for infantry units that often stalled just yards from where they started. That crucible forced gunners to get serious about accuracy. In the flat, cratered mud of Flanders, even being off by 50 yards could mean dropping shells on your own advancing infantry instead of the Germans. Forward observers who were up near the line built increasingly disciplined methods of adjusting fire. They used telephone lines, then later wireless sets, to call in small corrections. Techniques like the creeping barrage, a moving wall of fire that crept forward just ahead of friendly infantry, demanded the level of precision that older generations of artillery officers never thought would be realistic in combat. By 1918, the Royal Artillery had built up more practical firing experience than any other artillery branch on Earth. Officers had collected detailed firing data on everything that mattered: shell flight paths, how propellant behaved in cold or heat, how barrels wore out, and hundreds of other little variables that changed where a shot actually landed. These weren't clean test range notes. This was knowledge bought with 4 years of industrial killing. Roughly 1.5 million 18-pounder shells were produced during the war, and a huge portion of them were actually fired in combat. When the armistice hit in November 1918, Britain had thousands of 18-pounders in storage, in every condition imaginable. Some had spat out so many shells that the rifling inside the barrel was chewed almost smooth, and the tube needed replacing. Some had barely been used at all, having rolled off the line late in the war. All of them went into depots as the army shrank and the country tried to scrub the memory of trench warfare out of its mind. Through the 1920s, those guns sat in storage sheds, preserved and cataloged, but drifting toward obsolescence as other nations pushed ahead with new artillery designs. The knowledge, though, didn't evaporate. The Royal Artillery knew from bitter experience what actually made a field gun useful in modern war. They understood that accuracy was more important than raw blast power. They understood that mobility wasn't optional. If you couldn't get in, fire, and get out fast, counter-battery fire would kill you. They understood that crews needed to be able to set up and start shooting fast under pressure. When it was finally time to think about the next generation, those hard lessons from 1914-1918 would be built right into the blueprint. In other words, the 18-pounder's story wasn't finished. The 1920s were cruel to the British armed forces. The First World War had nearly bankrupted the country, killed close to 1 million servicemen, and burned through resources on a level even the British Empire had never imagined before 1914. The Treasury, desperate to get spending under control, started slashing defense budgets with a kind of cold enthusiasm. The so-called 10-year rule, adopted in 1919 and renewed again and again throughout the decade, basically said, we don't expect a big war for at least 10 years. That fiction gave politicians cover to keep the Army starving for funds, while the Royal Navy and the young Royal Air Force clawed at each other for whatever scraps were left. For the Royal Artillery, the message was brutal. Germany, even though it had lost the war, was already thinking about modern weapons for the future. France was investing in new guns. So were Poland and Czechoslovakia. Britain, meanwhile, couldn't afford to replace its old 18-pounders in any meaningful way. The guns were wearing out. The rifling inside those barrels slowly degrades over time, even if you don't fire the weapon. But designing a whole new field gun series from zero would cost millions of pounds that the Treasury flat out refused to approve. The technical officers at Woolwich were staring at a problem that mixed tactics with money in the worst way. The upgraded wartime 18-pounder had eventually reached a maximum range of around 9,300 yards, up from the original 6,500, but even that was starting to look short. Armies were becoming more mobile and fights were stretching out across longer distances. The caliber, about 3.3 inches, also wasn't delivering the explosive effect that heavier shells from other countries were starting to produce. But if you wanted to start over, that meant designing everything fresh. New barrels, new carriages, new sights, new ammunition, new training methods, literally a new system for a new army. The price tag was astronomical, and the Treasury wasn't bluffing. The money did not exist. So the gunnery experts suggested something that sounded reckless at first. What if they didn't build an entirely new gun family? What if they took the thousands of stored 18-pounder barrels and reworked them? Normally, you can't just open up a barrel to a larger caliber and assume it'll behave. But maybe, in this case, you could. Engineers ran the numbers and concluded that an 18-pounder barrel could be bored out from 3.3 inches to about 3.45 inches, which would allow it to fire a heavier shell. The new round weighing roughly 25 pounds, which is where the 25-pounder label came from. The walls of the barrel would get thinner, yes, but still strong enough to survive the pressures involved. This plan started gaining support in 1933 as the world situation got uglier. Adolf Hitler had just taken power in Germany, and while most British politicians tried hard not to think about what that meant, the people doing serious war planning didn't have that luxury. The director of artillery formally proposed converting the existing 18-pounders instead of waiting years for a perfect brand new system. It was realistic, it was cheap, and critically, it could be done fast using factories that already existed. Treasury officials liked it because it didn't explode the budget. Artillery officers accepted it because at least it would give them something usable in time. By 1935, the decision was made to move forward, and by 1936, the first test versions were already being evaluated. But the new 25-pounder wasn't just an old barrel with a larger hole. The engineers also built a completely new carriage, known as the Mark II, with features that were very modern for the time. Split trails that opened like a V for stability and traverse, plus a circular firing platform that let the gun swing through a full circle without dragging the whole thing around. The old 18-pounder barrel, now opened up to take the 25-pound shell, sat on top of this new mount. The result was a hybrid, proven old steel mated to a smart, up-to-date support system. On paper, this looked like a second-choice fix, the sort of patchwork solution people would later mock Britain for during the war. Critics pointed to German artillery development and said, "Look at them. They're designing purpose-built modern howitzers without all these weird compromises." But Britain's approach had a hidden strength. It basically forced the design team to be extremely sharp about every detail that wasn't the barrel. They couldn't just say, "Make it heavier," and walk away. They had to engineer accuracy and handling into every part. That made the problem more complicated, not less. Converting barrels wasn't as easy as running a drill down the bore. Each old 18-pounder barrel had to be individually examined, measured, and rated. Some had fired so many shells that the rifling was almost completely worn smooth. Those were scrapped outright. Others were still in decent condition and could be safely machined out to the new 3.45-inch internal diameter. This boring process demanded extremely tight tolerances. Being off by even a few thousandths of an inch could ruin accuracy or create dangerous pressure spikes when the gun fired. The ammunition was its own compromise. A 25-pound shell sat in a middle zone between the lighter 18-pounder round and the heavier howitzer shells used by larger guns. British ordnance designers settled on an 87.6 millimeter diameter, which also gave them freedom in how they loaded propellant. The gun could be fired with different charges. Charge 1 for close work at lower velocity, Charge 2 for medium engagement, and Charge 3 for maximum range. Later, a supercharge was added for extended distances. This adjustable charge system, borrowed from howitzer practice, gave the 25-pounder a kind of split personality. One gun could deliver flat trajectory direct fire like a classic field gun, and also high-angle arcing fire like a howitzer. The carriage design might have been the biggest leap. The Mark II carriage opened in a wide V and carried a circular steel platform between the trails. That platform let the crew rotate the gun through a full 360 degrees so they could engage threats in any direction without dragging the whole weapon around by hand. In the kind of fast-moving armored warfare that was about to define the Second World War, that mattered. German and American guns of the period usually managed maybe 45 to 60 degrees of traverse without repositioning. The British gun could simply swing all the way around. The muzzle brake at the tip of the barrel was another key part. It redirected the blast gases sideways and slightly backwards to soak up recoil force. That let a relatively light carriage survive the heavier blast of the new shell without the whole weapon leaping backwards violently every time it fired. Muzzle brakes weren't brand new tech, but the British pattern worked well, cutting the felt recoil by roughly 30%. The sighting gear received the same careful attention. The Mark II sight was built on 2 decades of wartime math and field notes. It carried fine range and deflection scales, spirit levels, so the crew could make sure the gun was sitting dead level before firing, and built-in adjustments for wind, air temperature, and even the temperature of the propellant charge. At long range, these things mattered a lot. A 25-pounder firing at its extreme distance, about 13 or 100 yards with Charge 3, would see its shells drift offline in even a modest crosswind. The sight allowed crews to dial in those corrections quickly. Based on information radioed in from forward observers, Factory work began in 1938 in Royal Ordnance plants across Britain. The process was straightforward but labor-intensive. Pull the 18-pounder barrel off its old carriage, ship it to a workshop, bore it out and re-rifle it to the new standard, pressure test it with overcharged proof rounds, then mount it on the brand-new Mark II carriage. Every single gun went through live fire acceptance tests before it was signed off. Production climbed as war started looking unavoidable, but by September 1939, only about 1,000 25-pounders were actually in service. The Army needed thousands. Once the war began, manufacturing ramped hard. The Royal Ordnance Factory in Nottingham became the main source for the new carriages, eventually turning out several thousand. Barrel conversion work was spread between different plants, so that German bombers couldn't knock the whole program offline in one hit. By 1940, output hit around 100 guns per month. By 1942, that monthly number had tripled. The cheap fix was now being built at industrial scale, and every gun coming off the line carried those carefully thought-out features that made the 25-pounder the most accurate field gun in any army. North Africa turned into the real field test. When British and Commonwealth forces deployed to Egypt in 1940 to stop the Italian advance from Libya, the terrain was nothing like northern France in 1917. No forests, no villages, no safe ridgelines, just open desert, rock, blazing heat that could climb past 50 degrees Celsius in summer and visibility for miles. There was nowhere to hide, for you or for the other guy. Fights became battles of movement and precision shooting, exactly the conditions that rewarded the 25-pounder. The Western Desert Force, which later evolved into the 8th Army, went up at first mainly against Italian units that outnumbered them in artillery. During Operation Compass in December 1940, British gun crews quickly realized they could hammer Italian positions from distances where Italian return fire simply couldn't reach them. The 25-pounder's 13 on 400-yard top end gave them standoff range. At the Battle of Sidi Barrani, Royal Artillery batteries dismantled Italian gun lines piece by piece, firing from beyond effective Italian range. The accuracy reports from that campaign were impressive. Observers noted that 25-pounder rounds were landing inside 50-yard circles at more than 10,000 yards. Then in February 1941, Erwin Rommel arrived with the Africa Corps, and everything changed. German artillery doctrine put huge emphasis on counter-battery fire, find the enemy guns fast and wipe them out. Rommel's gunners were experienced professionals equipped with capable systems like the 105mm LEF AH-18. The Desert War turned into a deadly back and forth in which artillery units had to shoot, then move, before German spotters could call down return fire on their position. The 25-pounder's full-circle traverse was priceless in that environment. Crews could go into position, fire in multiple directions as targets appeared, then limber up and relocate in minutes. At the Siege of Tobruk, starting in April 1941, Australian and British batteries used 25-pounders for both defensive work and counter-battery duels. The garrison had around 72 25-pounders, and they stayed active throughout the 240-day siege. German forces kept trying to punch through the perimeter, and each time, well-aimed British and Australian fire broke up the attacks. Rommel himself noted in his diary how effective British artillery was, complaining that he could not mass his troops without immediately drawing accurate, punishing British shell fire. The gun's accuracy wasn't just about the hardware. It was built into the way British artillery fought. British doctrine relied on centralized fire control. Forward observation officers, often positioned with the infantry, could call in strikes from multiple batteries at once. The 25-pounder's precise sights and variable charge system meant changes could be made instantly. If the observer radioed, "Add 200, right 50," the crew could spin in those adjustments and fire again, seconds later. German artillery, while deadly and well-drilled, tended to work more on a battery-by-battery basis with less immediate coordination. El Alamein, in October 1942, showed the 25-pounder at maximum effect. General Montgomery's 8th Army assembled roughly 900 25-pounders for the offensive, the biggest British artillery massing since 1918. When the attack began on 23rd October, those guns hurled more than 500,000 shells in the first 24 hours. But this wasn't just random area saturation. The fire plan was mapped with extreme care. German and Italian strongpoints, communication hubs, and gun pits were targeted with what witnesses later described as eerie precision. A German officer captured after the battle said British artillery seemed to know exactly where every headquarters, every battery, and every assembly area was located. By the time the Africa Corps surrendered in Tunisia in May 1943, British and Commonwealth gun crews had total faith in their weapon. They had watched it go toe-to-toe with German guns in terms of range, match them in rate of fire, and beat them in accuracy and flexibility. The gun that critics had written off as a stopgap conversion was now the standard everyone else was judged against. The 25-pounder's almost uncanny accuracy wasn't a mystery. It was the result of physics, mechanical consistency, and disciplined procedure working together. To see why this gun could land shots so predictably in tight groups, you have to look at the system as a whole. Every part, the carriage, the recoil system, the ammunition, the sights, the way it was fired, was built around the goal of putting rounds exactly where they were supposed to go. Start with the split-trail carriage. It sounds simple, but it changed everything. When the two trails swung open in a wide V, they created a broad, planted base that resisted side-to-side movement under recoil. Even with the muzzle brake eating some of the kick, the force of firing a 25-pound shell is serious. On guns with a single trail or a narrow carriage, recoil can nudge the whole weapon a little sideways, which changes the next shot's point of aim. The 25-pounder's wide stance meant it came back to the same firing line after each shot. Consistency like that is the base layer of accuracy. The circular firing platform multiplied that effect. That metal turntable under the trails did more than let the gun spin around to engage targets in any direction. It also gave the gun a stable pad that didn't deform as much between shots. On soft sand or wet ground, a normal carriage will dig in differently every time it fires, which slightly changes the barrel angle. With the 25-pounder, the platform kept things uniform. Crews could fire dozens of rounds and still hold the same point of aim. The sighting gear brought in lessons learned from millions of wartime shots. The number 11 dial sight, standard issue on the 25-pounder, had extremely fine markings for both elevation and traverse. Crews could set elevation in increments as small as 1/4 of a degree. To give a sense of scale, at 10,000 yards, being off by 1 full degree vertically means you can be short along by about 175 yards. The 25-pounder's sight let crews make tiny, controlled adjustments much smaller than that. They could walk fire onto the target with very little ammunition wasted. Ballistics also mattered. The 25-pounder fired a streamlined shell with excellent stability for its era. The copper driving band around the base of the shell gripped the rifling and spun the projectile at a consistent rate. That spin kept the shell from wobbling in flight and tightened dispersion. British quality control on ammunition was strict. Rounds from the same production lot were almost identical in weight, shape, and center of gravity. That uniformity meant that once a crew set a charge at an elevation, that gun would send out shell after shell along nearly the same path. The adjustable charge system gave crews one more layer of control. Instead of being stuck with a single fixed propellant load, they chose the right charge for the distance. Lower charges at close range kept the trajectory flatter and airtime shorter, which meant wind had less chance to push the shell off course. The end result was tight shot groups no matter what the range was. British crews also used detailed correction tables. Propellant burns differently when it's hot or freezing. Cold powder gives you lower pressure and shorter range. Hot powder does the opposite. Air temperature matters too. Barrel wear changes muzzle velocity. For long-range fire, even the rotation of the earth has a measurable effect. British fire control tables folded all this in. These weren't guesses. They grew out of thousands of recorded firings and careful math. If crews applied those corrections properly, the 25-pounder could put rounds into a roughly 50-yard circle even at maximum range. The Normandy landings on June 6, 1944, brought the 25-pounder back to European soil in force. Operation Overlord put about 400 plus 25-pounders ashore on D-Day, with hundreds more following after the initial landings. But this was nothing like North Africa. Instead of open desert, British and Canadian troops were fighting in close country. Hedgerows, hamlets, wooded lanes, orchard walls, and dug-in German defenses. The desert had rewarded long-range duels. Normandy demanded fast, accurate fire in support of infantry who were often fighting at point-blank distances. The bocage, those thick earthen hedgerows in Normandy that basically turned every farm field into a little fortress, created a nightmare for attackers. German machine guns, anti-tank guns, and mortars could hide behind these banks and stay invisible until they opened fire. Infantry couldn't move without shutting those positions down, but finding the exact firing point wasn't always easy. The 25-pounder excelled in that environment. Forward observation officers moved with the infantry. As soon as a German position exposed itself, the observer could radio for fire and get shells dropped in within minutes. Because the 25-pounder was so accurate, those shells could land only a few yards from friendly troops without wiping them out. Operation Goodwood in July 1944 showed just how organized British artillery had become. In that push to break out from the Caen area, Montgomery lined up roughly 700 25-pounders to prepare the ground. The bombardment ran for 3 hours and burned through more than 200,000 shells. But this wasn't a mindless storm of explosives like the First World War barrages. It was mapped fire laid on specific German strongpoints, headquarters nodes, and artillery positions identified by recon and intelligence. Afterward, reports described entire German units basically shredded before the British armor started moving. As the campaign rolled forward, the 25-pounder kept proving how adaptable it really was. In house-to-house street fights in Caen, crews fired at extremely short distances, sometimes under 2,000 yards, using Charge 1 to lob shells directly into buildings the Germans were holding. A few weeks later, during the breakout toward Falaise, the very same guns were blasting retreating German traffic columns at long range. The fact that a single gun type could handle both extremes made British artillery support incredibly flexible. River crossings were the ultimate test of timing and coordination. At the Rhine crossing in March 1945, Operation Plunder, British gunners staged one of the most complex fire plans of the war. More than 3,000 artillery pieces were involved, including over 1,000 25-pounders. The plan called for timed fire concentrations on specific targets, smoke screens to blind German spotters, and controlled creeping barrages that walked ahead of assault troops. That only worked if shells landed exactly where they were supposed to. The 25-pounder's consistency under pressure helped make that possible. After the Rhine was forced, German artillery officers captured by the Allies kept saying the same things in interrogation. They talked about how fast British guns could respond to a fire request. They talked about how accurate that answering fire was. And they complained about how difficult it was to hit British batteries with counter-battery fire because those batteries simply didn't stay in one place. One German officer said that British guns seemed to know exactly where we were at any moment. That wasn't magic. It was the fully linked British artillery network of observers, command posts, and gun lines acting together. By the time Germany finally surrendered in May 1945, the 25-pounder had fired millions of shells across France, Belgium, the Netherlands, and Germany. It had supported every major British and Canadian move from Normandy to the Baltic. Field Marshal Montgomery, who was famously careful with praise and had fought in 2 world wars, called the 25-pounder the best field gun of the conflict. Coming from him, that wasn't casual flattery. The weapon that had looked outdated in 1939 had proven itself to be the most capable all-around field gun in the European theater. If you talk to Royal Artillery veterans who served on the 25-pounder, you hear the same notes again and again: reliability, accuracy, and a kind of loyalty to a piece of equipment that never betrayed them. Those voices give you something the numbers don't: what it actually felt like to work that gun in real combat. These weren't design engineers. They were men whose lives depended on that weapon doing exactly what it was supposed to do, exactly when it was supposed to do it. Sergeant William Ross of 2nd Regiment, Royal Horse Artillery, who served in North Africa, remembered the quiet confidence the gun inspired. You knew exactly where your shells were going. Jerry could throw bigger metal sometimes, heavier shells, longer range in some cases. But we could hit what we aimed at first go every time. That's what kept us alive. Versions of that line show up in a lot of veteran accounts. It wasn't just about killing the enemy faster. It was about being able to trust under fire that when you called for a shot, it would land where it needed to. German batteries might spend dozens of ranging rounds trying to walk their fire onto a target. British crews expected to nail the aim point with their 2nd or 3rd shot after initial adjustment. Running the gun was brutal, physical work. A 25-pounder section in combat usually needed 6 men working like a machine. The gun commander listened to the fire orders and translated them into sight settings. The layer handled the aiming gear, elevation, and traverse. 2 loaders worked the ammunition, one lifting and inserting the shell, the other ramming it home, and then putting in the chosen propellant charge. The breech operator slammed the breech shut and cracked it back open after each shot. The last man yanked the lanyard that triggered the firing pin. In a practiced gun team, the time from receiving a fire mission to the first round leaving the barrel could be under 30 seconds. Bombardier James Mallister, who fought in Normandy and then into Germany, described what sustained fire felt like. Your hands would be raw, ears ringing even with plugs, eyes burning from the propellant smoke. The barrel so hot you wouldn't dare touch it. We'd fire for hours, hundreds of rounds, and your whole body would just be shaking from the shock wave. But the gun never stopped, never jammed, never failed. You kept feeding it, and it kept throwing shells exactly where they were supposed to go. Maintenance wasn't optional. It was survival. After heavy firing, crews had to clean out the barrel to scrub away propellant residue that could mess with accuracy. The recoil system, hydraulic cylinders, springs, seals had to be checked constantly. The breech needed cleaning and oiling. The sights had to be confirmed and, if they had drifted, brought back to zero. Gun crews took pride in this, or they'd stay up through the night in muddy positions doing checks and wiping down metal so their gun would be perfectly ready again at first light. The full-circle traverse feature in particular earned respect from the crews who'd faced German counter-battery fire. Gunner Thomas Bradshaw, who served in Italy, explained it like this. Jerry was quick. He'd see our muzzle flash and start dropping mortars and shells on us fast. With the 25-pounder, we could swing the gun to shoot in a totally different direction without having to lift the whole carriage. That saved our skins more than once. You'd be firing north. Jerry starts walking shells onto you. You swing east, loose a few rounds, and then you hook up and move. The old 18-pounders couldn't do that. You had to drag the whole thing around by hand. Some of the most interesting comments came from British gunners who later worked alongside American artillery units. Lieutenant David Morton, who acted as a liaison with U.S. batteries in 1944, said it this way. The Americans had a very good gun in their 105mm howitzer, no one's arguing that. Solid weapon, but they were surprised how few rounds we needed to shut something down. They were trained to blanket an area. We were trained to kill the point. It's just two different schools. They respected what the 25-pounder could do, even if they weren't going to admit it publicly. The end of the war in Europe did not mean the end of the 25-pounder. In some ways, it was only the start of Phase 2. Within months of Germany's surrender, British and Commonwealth units were getting reassigned all over the world, and the 25-pounder went with them. The gun that had proven itself in North Africa, Italy, and Northwest Europe would keep firing in real combat for the next 5 decades, on almost every continent except South America. Korea was the next major trial. When North Korea invaded the South in June 1950, British and Commonwealth troops deployed under the UN banner, and they brought their 25-pounders. Conditions in Korea pushed the gun into extremes it hadn't seen before. Winters that dropped to minus 30 degrees Celsius. Steep mountains that made moving guns a nightmare. Enemy forces using Soviet-style artillery tactics and equipment. The cold alone caused chaos. Hydraulic fluid in the recoil system turned thick. Propellant burned unpredictably when it was frozen. Crews were trying to work bare metal in gloves with numb fingers. And still, the gun adapted. Special low-temperature lubricants were issued for the recoil system. Powder charges were kept warm in heated dugouts and only brought forward right before firing. Range tables were adjusted to reflect the bitter cold. At the Battle of the Imjin River in April 1951, British 25-pounders from 45 Field Regiment kept the Gloucestershire Regiment alive as Chinese forces tried to overwhelm them. The guns fired almost non-stop for 3 days, dropping more than 10,000 shells and smashing repeated Chinese assaults. British infantry positions were so close to the attackers that the gunners sometimes had to land shells within 100 yards of their own men. Precision under that kind of pressure wasn't a luxury. It was the difference between holding and being overrun. The Malayan Emergency from 1948 to 1960 was a totally different fight. Instead of open battle against an organized army, British and Commonwealth forces were hunting communist guerrillas in dense jungle. Visibility in some places was 20 yards if you were lucky. The 25-pounder was set up in fire bases, hacked out of the trees, ready to drop sudden fire wherever a patrol ran into trouble. Speed mattered more than anything. Crews would get the gun into position, fire a mission on demand, and then shift location within 15 minutes so they wouldn't get ambushed. Suez in 1956 showed the gun's mobility in a dramatic way. During the Anglo-French attempt to seize control of the Suez Canal, British airborne units dropped into Port Said. And yes, 25-pounders were actually airdropped in special containers, then unpacked, assembled, and brought into action within hours. That rapid deployment trick had been developed in theory during the Second World War, but Suez was one of the few times it was demonstrated so boldly. Politically, Suez was a disaster, but in purely military terms, the gun once again did exactly what was asked of it. India and Pakistan both inherited 25-pounders after independence, and both used them in wartime. Pakistani gunners fired them at Asal Uttar in 1965. Indian units used them throughout the 1971 war that led to the creation of Bangladesh. Israeli forces also captured and reused 25-pounders taken from Arab armies during the early Arab-Israeli wars. The gun popped up on both sides of multiple fights all over the world, which shows just how widely it had spread among Commonwealth and former Commonwealth nations. The 25-pounder's last major shooting war under the British flag came in the Falklands in 1982. The main British artillery piece for that campaign was the more modern 105mm light gun, but a few 25-pounders still saw use in supporting roles. Think about that. Nearly 4 decades after the end of the Second World War, commanders still considered the weapon reliable enough to ship to an active war zone. New Zealand didn't finally stand down its last 25-pounders until 1989. The Indian Army kept theirs into the 1990s. Some small countries reportedly still had them in limited service into the early 2000s. That makes the 25-pounder one of the longest-serving field guns in history. The production numbers tell you why. Around 12,000 25-pounders were built between 1939 and 1945. They served with Britain, Canada, Australia, New Zealand, South Africa, India, and many other nations. Some were destroyed in combat. Some were cut up for scrap after the war, but a huge number stayed in service for decades after their first shots were fired. That kind of staying power raises a question historians still argue about. How did a gun based on a 1904 design, rebuilt from obsolete barrels to save money, end up outperforming and outlasting modern artillery purpose-built by richer nations? The answer isn't especially comfortable for big defense bureaucracies. Take the German LAF H-18, a 105mm howitzer created in the 1930s specifically for modern war. On paper, it looked better. It fired a heavier shell. Its range was competitive. It was marketed as a new generation weapon. But it never earned the same reputation for accuracy that the 25-pounder did. It was also heavier, harder to shift, and it didn't have the 360-degree traverse that made the British gun so adaptable under fluid battlefield conditions. German doctrine leaned on overwhelming fire volume. That approach worked brilliantly as long as you had mountains of ammunition. But as supply got tight later in the war, that doctrine became harder to sustain. The British philosophy, hit the target with as few rounds as possible, turned out to be more efficient across a long, grinding conflict. The American 105 mm M2A1 howitzer was also an outstanding weapon. It served the U.S. Army extremely well in Europe and the Pacific, and stayed in service for years afterward. It was tough, it hit hard, and it could be mass-produced in huge quantities. But even American gunners sometimes admitted the British gun had an edge in pure precision. That difference came down to design priorities. U.S. artillery doctrine assumed that victory would come from scale, lots of guns, lots of shells, enormous fire missions. In that system, a tiny dip in precision didn't matter. The British approach, shaped by financial limits and bitter First World War lessons, treated precision as the starting point and accepted a lighter shell as the price. Both ideas worked, but they were solving slightly different problems. The British conversion program forced ruthless efficiency. Because they couldn't throw money at a brand new design, they had to refine every component and every process around performance. You see the results in features like the circular firing platform, the advanced sights, and the flexible charge system. Those aren't the kinds of details you always get when you start with a blank check and a blank sheet of paper. Sometimes lack of money creates focus. The 25-pounder was, in a sense, 20 years of artillery experience turned into hardware. Every part of the gun carried lessons from the Western Front. The split trail layout fixed the stability issues that had haunted the older guns. The muzzle brake handled the recoil of a heavier shell without needing a huge carriage. The sighting gear baked in firing corrections that gunners used to calculate by hand under fire. It was, in a way, living memory in metal. Post-war tests by several armies kept ranking the 25-pounder as the most accurate field gun of the Second World War. British trials in the 1950s even compared it with newer designs and still found it highly competitive in precision, even if other guns had more range or threw heavier shells. Its accuracy came not from one miracle feature, but from lots of small advantages adding up. A stable platform, excellent sights, consistent ammunition, and highly trained crews. No single piece made it legendary, the way all the pieces worked together did. The gun's long life also says something about toughness and adaptability. On paper, an artillery piece from the 1940s should have been retired by the 1970s, replaced by systems with longer range, smarter ammunition, and more advanced materials. The 25-pounder hung on because it kept working in real conditions that wrecked more delicate gear. Sometimes simple, well-engineered tools survive where complicated, advanced systems break. The 25-pounder had fewer points of failure, could be fixed in the field, and could be run by crews who didn't have years of specialized training. There's a bigger lesson in all of this about how militaries buy weapons. The 25-pounder succeeded because it was built to solve a specific real problem, provide accurate, reliable field artillery fire to support troops. It wasn't chasing buzzwords. It wasn't trying to be the biggest gun or the flashiest gun or the most futuristic gun. It was trying to be the most effective gun for the actual job. Defense institutions often forget that. They fall in love with cutting-edge complexity and start believing that expensive and modern automatically means better. The 25-pounder is a quiet argument against that way of thinking. The obsolete gun that wasn't obsolete at all, a weapon born out of budget desperation and old barrels, became the standard by which field artillery was judged. It proved that careful engineering, hard-earned experience, and a clear sense of priorities can beat raw technical novelty. The 25-pounder didn't just help Britain win a world war. It shaped what a field gun was supposed to be for the next 50 years.